So regarding the GenB project, its main objective is to raise a future generation that is aware, sensitive, and interested in environmental issues, sustainability, and circularity. But how do we do that? We do that by co-creating innovative approaches with teachers, parents, and young people, by providing formats, materials, and toolkits on bioeconomy and the bio-based sector. You can find the link here in this slide and even a barcode for you to access materials like that. And we also organize events like this webinar to promote bioeconomy as a field, even careers, and spread information. So without further ado, I would like to present our two speakers, Tanya Meyer and Zofia Karar. They're both working at the Base Europe PilotPlant. I hope I said it right, but please correct me if I'm wrong. Tanya is a European project coordinator there, and Zofia is a project acquisition coordinator. So, as I said, without further ado, I leave the floor to you. Could you please present yourselves and show us what you have prepared for us today?
Yes, sure. Thanks, Nicolas, for the kind introduction. Good afternoon, everybody. I will start introducing myself. So I'm working at the Base Europe PilotPlant since around 7 years. My background is in, I have a diploma engineer from Germany on bio and nanotechnologies and a master in technology and innovation management. And I'm mainly working in the project acquisition team, actually having the same role as Joffrey. So we are looking into acquisition of new project proposals, matchmaking, networking, but also project implementation and project coordination.
Then I will continue. So my background is I'm bioengineering, and I did my diploma at the Budapest University of Technology and Economics, and also continued my PhD in the biorefinery area. And I have been working in academia for a long time, until 2019, mainly in Denmark, when I decided to leave academia and to join the real world and get this position at Base Europe PilotPlant as a project acquisition coordinator. And today we prepared a short presentation together with Tanya about biorefinery in general. So we will go through what is the biorefinery, what we are doing at Base Europe PilotPlant, also to show some of the projects that we are participating. We also brought some short movies, so we hope that it will entertain you, so it's not only just us who are talking all the time. And also we have been asked to tell a bit about the skills and the professionals that we have at Base Europe PilotPlant. And of course, if there is any question at the end, we will be happy to answer them. So to start with, what is the definition of the biorefinery? We were not sure how familiar everyone is with this definition, so therefore we thought about to bring this first slide here. Probably you are all familiar with the oil refinery definition that you can see on the left hand of the slide. When we are using fossil-based resources, like for example the oil, to produce different kind of chemicals, and from these chemicals different kind of products. What is the problem with that? That you can see that the CO2 in the left upper corner, it's not recycled, since all the carbon that we have in the oil present, we are not recycling it in the system. And of course, all these chemicals products, when they are getting into the environment, they are causing a lot of problems. You can hear a lot about microplastics these days, or you can also see all these turtles in the seas wrapped up in left behind fishing nets, for example. If you look at the right hand of the side, this is what is biorefinery all about it. So in the biorefinery, it's very similar to the oil refinery. The difference is that in the biorefinery, we are starting from biomass. So it can be, for example, agriculture waste byproduct, not waste, we do not like to say waste, we like to say byproduct. For example, it can be wheat straw, it can be corn stover, but you can also consider industrial byproducts, for example, from the sugar production, the molasses. So all this could be also used as a source to produce exactly the same amount of building block or chemicals that are produced in the oil refinery, and we can produce the same end products at the end. But as you can see, the CO2, that way it's getting recycled in the system. So that's the main advantage of using biorefinery instead of oil refinery. And of course, we are also avoiding some of the pollutions from the end products that I have been mentioning before. Just to show you some of the examples when we are talking about chemicals or products that we are using. Maybe this slide is not the best and it's quite small, but I think it gives a very nice overview that basically it's every day, every time we are touching that it's a fossil-based product. So you can see on the left hand of this slide that we are using a fossil source. You can see in the middle all the chemicals that we are producing from these fossil fuels, and you can see all the intermediate compounds that are ended up in the end product on the right hand side. I do not know how much you can see, but you can find it in food packaging, you can find it at the table where you are sitting, this material. You can find it in toys, you can find it in cosmetics, you can find it in toothpaste. So it's all around us every day, every second. We are in contact with these fossil-based products. So the idea with the biorefinery, it's exactly the same figure as you can see here, but you can see that on the left-hand side, instead of using oil, we are using for example, cellulose and hemicellulose. These are the building structure, for example, for agriculture byproducts. And we are producing exactly the same building blocks and the same chemicals from this material, and we can replace the products that are listed on the right hand side. And probably you can also find some of these bio-based materials in your everyday life. For example, if you go to a supermarket, you can find these bio-based plastics already that you can buy the vegetable in. So that's the main difference between the oil refinery and the biorefinery, very short. And now Tanya will continue. You are muted, Tanya.
Yes.
One button I forgot to push from all the 5. So I was going to say, in this slide, I'm going to talk about our, what we call playground, the circular bioeconomy. As Jocky explained already, again, on the left side in the illustration, you can see like really the black carbon coming from fossil resources, which is more a linear approach. There were already a couple of examples mentioned on this. But now with our work and our work of our network, we try to bring in organic biomass, green biomass, what we call like a green carbon, also very much a green carbon dioxide, and make this approach circular, so that the biomass that we can use in our bio-based products or biodegradable products can be reused, and we try to maximize as much as avoiding, again, using fossil resources to integrate in this circle. So this has not only like economical impacts, but also it's addressing social challenges like greenhouse gas emissions. There's a lot of reindustrialization going on. It's creating new jobs and new types of jobs as well. And it, of course, enables the local industry because it can take up and encourage local renewable resources and businesses. So that's why we will further on give you some more examples. We go from like a linear fossil economy over a circular fossil economy. So at the moment we are in kind of a transition phase, which is hopefully soon over, towards a circular bio-based economy. So it cannot be touched upon all of these things, how to come from economy to actually technology. So that's also our playground, the key enabling technologies, and especially the industrial biotechnology and the bioeconomy. So there are some different fields of biotechnology. So maybe you are more familiar with the red biotechnology, which are touching on technologies related to medical challenges like vaccines and insulin, for example. Then more what they call the green biotechnology, everything that involves like plants, like for insects, diseases, agricultural points of view. And then we also have what they call the white biotechnology, which is called the industrial biotechnology. For example, enzymes used in washing powders. So you already have these examples also in the supermarkets to buy. So in industrial biotechnology, that's really the application of biotechnology for an industrial processing and industrial production of chemicals, materials, and fuels. And it really includes kind of the practice of using microorganisms or compounds of microorganisms, like the enzyme that I mentioned already, but also bacteria, yeast, fungi, and algae. And these substances could create some chemical building blocks that, again, have specific properties or capabilities so that it can actually substitute the fossil-based materials. So to bring this a little bit closer to you, actually we have made a really nice example of a real project, a European funded project. You can also find it online. It's called Waste to Funk. And yeah, it's been just released a couple of days or a week ago. So you're one of the first who are going to see it, and we really hope you will like it. So I will shut up and I will let you enjoy this video.
Once upon a time, in a world not so different from ours, mankind relied on a magical substance called crude oil. It was a game changer to be found in almost everything in our daily lives. Toys, lunchboxes, drinking bottles, shampoo, and yes, even in your toothpaste. But my little friends at the time came to realize that we can do better.
Why?
Great question, little hero. You see, crude oil is an amazing resource, but not very kind to our planet. That's why we've embarked on the new adventure, using rather unexpected resources, such as food waste. In the enchanted lands of Waste to Funk, we use the magical conversion technologies of Amphistar and W to turn food waste into extraordinary things, like biosurfactants for cleaning products and personal care, or lactic acid for plastic packaging material.
No way!
Yes, way. Now let me take you on a journey to discover how we did it. Ready? Our adventure begins with preparing a feast for our tiny superheroes called microbes. We take leftover food, cut it into little pieces, and mix it with water. Then, we let the enzymes do their magic. For a pre-conversion quality check to ensure our microbes will love their meal. Guess what? Approved! Our tasty broth is ready for fermentation. We transfer the pre-treated food waste into large fermentation vessels. Now it's time for the real heroes to shine. Microbes.
Are those the superheroes?
Yep. Like the yeast of Amphistar and the bacteria of W, our microbes start eating and multiplying. And then all together start working their magic, producing tons of amazing biochemicals. When the spell is over, The vessel contains our precious biochemicals that we need to filter out before we can move on. So, my little heroes, buckle up now for a new era, from waste to wonders. Time now to hand over the purified biochemicals to powerful wizards that use them to produce sustainable cleaning products like EcoVer, or to make toys, lunchboxes, shampoo, drinking bottles, and yes, even toothpaste. The technology is ready. Are we? The end? Oh no, my friends. This is only the beginning.
So this short movie, it's available on our YouTube channel. I have seen that Nicola already put it in the chat. Thanks a lot. And for your information, it's not only in English, but it's translated to some of the languages like Dutch, Spanish, German, Italian, and maybe I forget something, but it's all on our YouTube channel. So you will find it there. In this short movie, you have seen some of our pictures taken at Base Europe PilotPlant. So you could see that we are actually working with huge fermenters and reactors and all that. So you might be wondering, why do we need to do upscaling, or why do we have such a big vessels? So when a new process in the biorefinery area has been being developed, usually it's taking place in small scale. So that means that in milliliter or in maximum in liter scale. But since we are talking about bioprocesses where we are working with microbes, for example, the ones that Tanya showed you, it's very difficult to scale it up, because by scaling it up, so that means that by increasing the volume of the reaction to 100 liter, then to 1000 liter, or to 10,000 liter, or even bigger, that will be required later on for the production, for industrial production scale. The microbe is not necessarily working the similar way as it's working in the lab scale. So therefore, you need to do these so-called upscaling steps to make sure that your idea that you have, it's really scalable and can be industrially produced later on. What is the problem? This slide might be a bit technical, but I will try to explain. So what you can see here, the blue, it's showing the technology risk. The blue line is showing the technology risk, and on the x-axis you can see the time. So at the beginning of the project, you have usually a high risk of that technology because you are not sure whether if it's working or not working. But at that time, the capital requirement, so the money that you have to invest in it, which is represented by the yellow line, usually it's very small, because you need small scale equipment, small amount of materials, and so on. If you look at the time frame, at the end of the time frame, so when you already know that your process is working and you can perform it in 10,000 liter scale, then the technology risk, the blue line, it's already very low, because you are sure that it's working. On the other hand, the capital investment, it's of course big, because you need to buy all these huge vessels. However, if you look at in the middle phase of this figure, there is one point that it's both the technological risk and both the capital investment, it's still very high. So you need to have a lot of investment to build some of this big equipment or to have some of this equipment, but you are still not sure whether your technology will work or not. And this is what they call the valley of death, because this is some ideas when they can die out because you do not have the necessary equipment. So therefore, we have, like, for example, Base Europe PilotPlant, which is able to bridge over this valley of death, because we have all the big scale equipment. So the people who do not have availability to scale up the process, they can come to us. And this is the service that actually we are providing for startups, for SMEs, for universities, for research institutes. So a short introduction about our company. So we are a multi-purpose pilot facility that is working on process development, scale-up, and also on custom manufacturing, focusing on bio-based products and processes. The company has been founded in 2008 and in operation in 2010. And right now we have 180 employees at Base Europe PilotPlant, and we are a fully independent service provider, and we are also an open access facility. So that means that it's possible to come and visit us, and sometimes university groups also organizing visit to come to visit our facility. So there is also a possibility for that. The company is located in Ghent, very close to the Dutch border. So it's like 10-15 kilometers approximately from the center of Ghent in the industrial area. And I do not know how much you can see it, but it's here in this area, so next to the bridge. So it looks very small from here, but it's quite big if you come and to visit us. So this is a bit better overview that you can see our facility, that we have different pilot halls. These are the ones that are highlighted here in blue. And Tanya will show some of the pictures from this pilot hall, so you will have an idea how they look like later on. Of course, we have a big building for offices. This is where also our clients, they can be on site if their process is running, so they can follow up closely, you know, what's happening, how the microbes are behaving. And of course, we have also corresponding laboratories where we do all the necessary analytical work and all the supporting technical services, storage, and so on. And now Tanya will tell you a bit more about the one-stop shop concept.
Yes, so now you got a first good impression about the facility and a good introduction. And I would like to explain once again why Base Europe PilotPlant, why we see it as a kind of a one-stop shop. So like one entrance point for a customer, for a client, for a new startup, developing some bio-based innovation, let's say. So the idea of the one-stop shop is that we take any kind of biomass, we can pre-treat this biomass, and then we can use different technologies to convert this biomass. So for example, a biocatalysis using enzyme to convert biomass. Gas fermentation using syngas or off gases as feedstock, or normal fermentation. Green chemistry, for example, for extraction, some compounds from plants, but also animal cell culture. So you might have heard about alternative proteins for meat purposes. So these are all technology that can convert biomass, but then we also need another technologies or lots of different other technologies for purification of this refined product. So the downstream purification, the end purification of the final products is quite substantial. So this is also included in what we call the one-stop shop. So for biomass, Geoffrey already mentioned some examples, but biomass for us could be like agri-industrial byproducts, bagasse, beet pulp, algae or marine biomass, paper, pulp, any kind of oils and fats, syngas, as I said before. And then as a refined product, as a substitute of a fossil-based products, we have the bio-based chemicals and the bio-based building blocks, the industrial enzymes, the bio-based enzyme solvents that are bio-based, etc., etc. So surfactants you saw in the video from the waste to funk, but also fuels, bio-based fuels, for example, could be a refined product. So how does it look like now in the Base Europe PilotPlant? So I will just quickly go through and give you some insights into our process salts. There's also a video on our YouTube channel where you can actually sit in a little plane, and we will take you in 2.5 minutes through the pilot plant. So maybe this is also interesting for you. So there's a drone flight video as well. So yeah, this you see our large fermenter. It's been updated, so we have the largest 75 cube fermenter, which is not in the picture yet. The green chemistry and ethics proven process hall on 5,000 liter, analyzing and process optimization lab, and then of course lots of storage space for the different kinds of biomass. So this is also what we do. So the services, we are a service provider, open access, multi-purpose, because there are many, many different technologies and companies also. We do process development for our clients. We do scale up from different technology readiness level. And we also do some custom manufacturing. So to really already provide the client with some application material that they can test for their own clients and to bring first application material on the market. So again, now I would like to show you and entertain you a little bit with a video, because this could have been a little bit more theoretically, but what we for sure have in Base Europe PilotPlant is a great amount of humor. So I would like to introduce you to the next video, which is about a real project as well, Rehab. And yeah, I will leave you with this, and I will start the video.
Welcome to Base Europe PilotPlant. We can do amazing things here, like turning this bark into 2-3 butane diol, and all process steps under one roof.
The bark goes into the pulper for size reduction and extreme mixing with water. Let's pulp up the value.
We sent the pulp through the jet cooker to break open the cells under high pressure. But hey, no pressure, no diamonds.
The chamber filter press separates the wooden sugars from the biomass. And now, next step, solid liquid separation, the centrifuge.
All done here. Let's bring these precious woody sugars to the fermentation hall.
Welcome to the beating heart of Base Europe PilotPlant. Here is where the magic happens. Using bacteria, glucose is converted to 2,3 butane diol. We constantly monitor the quality of your product and can produce food grade.
We also have large DSP equipment to purify our products in an efficient way.
To get the butanediol out of our fermentation broth, we use green solvents in our explosion-proof process hull.
So relax and don't bark up the wrong tree. Come to BBEPP.
So this short movie is again available on our YouTube channel, so you can easily find it there as well. So all these short movies that you have seen here, these are usually consortium-based projects. So that means that we are participating in many European founded consortium-based projects. So together with research institute, with companies, we are working on developing some of these new bioprocesses. And on our YouTube channel, you can also find some of these short movies for other consortium-based projects. Also, if you are interested to see more about the projects, you can find them on our webpage. This is the one that gives a lot of visibility for our company. This is what we can openly also communicate about it, but we are also participating in many bilateral projects. So that's B2B projects, and these are usually confidential ones, so we are not allowed to disclose them. Some of the big companies that we have been working together, they had some testimonials that you can also find on our YouTube channel. It's a lot of advertised to our YouTube channel here. And of course, both in the consortium-based project and in the bilateral projects, we are working on technology development as well. We have been asked to tell a few words about which kind of skills or which kind of jobs you can find in this area. So I brought here this picture that I know it's not the best, but I used it a lot when I was teaching and when I started to teach bachelor students or undergraduate students who were interested in the biotechnology, because biotechnology, it's a very complex one. So I do not know how much you can see it on this picture, and sorry again for the quality, but on the top of the tree, it's representing basically all the products that we can produce from biorefinery. And that's why it's the tree, of course, because as an example that it's a biorefinery. So there you can find, for example, food or feed ingredients. You can find chemicals that are used for polymer, or you can find fuels and so on. And to produce all that, you can see the roof of the tree, that it's not really only one topic that you have to implement here. It requires a lot of different skills. So it requires a bit of microbiology, a bit of biotechnology, genetic engineering, also pure engineering, and all that together in the middle, in the tree, that the biotechnology that can actually help us to produce all these compounds at the end of the day. So if some of the students would ask you, which kind of skills or which kind of studies they have to take to work on this field, it's very broad. But just to give you some examples, somehow the pictures are not coming in. Okay, there should be more pictures here, but for some reason it's not really coming in. Sorry for that. So it's
perhaps Zofia, sorry to interrupt you.
Yeah.
Maybe it's also an action that you have to press the next slide to appear as a movement. I don't know if that's what you were looking for.
No.
Oh.
No, I'm pressing everything, but it's now they are here. Okay. I have found them. So sorry for that. So which kind of interest or which kind of work they can do? Of course, it's a lot of things related to microbiology. So whoever likes to work, is, for example, with microbes. I know that for me, it's all started when I was a child and I get a microscope. And then I get, very fascinated that I can see a lot of things under the microscope. And this is what I started actually my journey. And I didn't know that I will end up in biotechnology. I just liked very much, and I was fascinated by the fact of seeing small things under the microscope. And of course, if you are much more interested, to not just to work with microorganisms, how to grow them, but you could also like to look into a bit deeper how they are actually working to understand the biochemistry. Also, if you would like to even go deeper, to understand on gene level how you can make all this modification, it's all very valuable skills, because you need all these skills, for example, to develop continuously the strains, or to identify new strains that are used in biotechnology. Also, some people are much more interested more in the analytical side of all this biotechnology. So you can also, go to this direction. You will also learn about analytics, how to measure all the things that we are producing during the fermentation, for example, because you need to be able to follow what is actually produced. And it's also just a standalone science itself to understand how you can analyze all these compounds that we are dealing on a daily basis. But of course, biotechnology also includes a lot of engineering. So also the people who has a bit more talent, to engineering or to steels or to big equipments, they can also find very interesting field, because they can do also, a lot of modeling. A lot of these processes actually are using different softwares for modeling and predict how the process will go on. And of course, as everywhere nowadays, the artificial intelligence is also coming more into the biotechnology. So also people with this interest, but somehow has the heart to the biotechnology, they can also easily find connection. So the students who are also interested more in designing things, bioprocesses, engineering, they can also find very interesting areas here. And to finish it up, this part and almost the end of the presentation, we also brought you a very short movie just to show you an example what a bioprocess engineer is doing at Base Europe PilotPlant. And of course, you can also find it on our YouTube channel, and you can share it with the students if they are interested, however they looks at as a bioengineer. So enjoy it.
Overall, there are not two identical processes, so that means that every single day, every single week, you will learn something new. It's a mind of learning. I'm Miguel, I come from Spain. I have been working at Base Europe PilotPlant for 2 years as a process engineer. As a process engineer, you will face a wide range of different processes, and you are in charge of preparing and executing them. It involves from logistics to project management and a lot of engineering. Mostly what I like my job here is because it's extremely engaging. You work with a huge variety of different processes, different microorganisms, different techniques, and that along with the work environment, how much you can learn and how extremely passionate the workforce is. It's just a great place and a fun place to work at. The excitement of everyone is just contagious, and you cannot avoid just being dragged into their own passion. As a foreigner, I started here when there were not that many expats, but in time the expat force kept on growing, and now we are quite a large group of expat people from all over the world. Originally, I'm from Barcelona, and I'm very proud of my city, but I have to say that once I moved to Ghent, I really just fell in love with the city. It's such a welcoming and warm city with a great atmosphere. I would describe myself as somebody who cannot stay all the day in front of my desk, and luckily this place is some place that allows me to keep on moving due to the large amount of activity happening at the same time.
So this is how a bioengineer days looks like at Base Europe PilotPlant. But of course, people are also, there are a lot of different roles, and we try to summarize it here on this slide, because we also have technicians, and technicians are also very crucial to our company, who are not necessarily, you know, designing, going into the process, but doing the everyday life. As I mentioned, of course, we have also a technical support department who are really helping to maintain the equipment, try to fix the equipment, you know, if something is happening. Of course, we have logistics and lab operators in place, but you can find all this on this slide. And of course, we are also the business developers, the people who are responsible for the projects, the accountants. So we have really different role at our facility. So I will give the floor to Tanya.
Yeah, indeed. So it's not only the bio-based innovations that are so multidisciplinary and multi-skilled, it's also actually the people that are behind it. So actually, we are already at the end of our presentations. I don't know, for some reason, we had a lot of promotion for the YouTube channel, because yeah, it really shows that we can visualize a lot of things very nicely for the public projects that we are involved in. But yeah, if you want to follow up every, let's say, news, then you can also follow us on the LinkedIn. So we have a LinkedIn account with over 13,000 followers at the moment. So they're actually the news, they are always shared there. And yeah, this is already the end of our presentation. So I hope you could really follow nicely what we try to bring to you, like starting with the problem with the fossil based situation, the transition situation that we are in right now, and that we want to change it to a bio innovation and bio-based materials and products to also solve the societal challenges a lot that you're confronted with a lot in the news as well. So we will stay around for another 10-15 minutes, and if you have any questions, I think you can put them in the chat, as Nicolaus said. And with this one, I thank you very much for your attention. Geoffrey and me, we enjoyed really much to put this presentation together and to try to explain what our heart is working for. Thanks.
No, thank you. Thanks both of you. It was indeed a brilliant presentation, and I imagine that the participants will have the same ideas as me. I could really sense your enthusiasm about what you're doing, and apart from that, also the level of your knowledge. So thank you. And we do have one question, actually two, from the participants at the moment, and then I also have some of my own. But so, okay, to take Georgia Laskari's question, she asked whether there are more videos or other materials like lesson plans that they could possibly use for their teaching, to inform their teaching and to share them with their students. From what I understand, your YouTube channel will provide a lot of those videos, if I'm not mistaken. So make sure to hit the link and follow them on their YouTube channel. And apart from that, I'm going to take control so I can take this presentation a few slides back. When it comes to learning scenarios and something more pedagogical, you can always check the GenB library. You can do this by clicking this link at the end of the slide, or scanning the barcode, and by doing so, you will be able to you will be able to have access to a lot of lesson plans, materials, games. There are a lot of interesting things for you to explore there. And another question from Christina Elena, she asked whether green biotechnology is about genetic modification. And for that, I will need to pass the floor to the experts.
I mean, you worked in this field, I think.
Yeah. So Indeed, if you are working on the microbe part, you will need. It's not necessarily that you will need to do genetic modifications, but it can be that sometimes you need to do genetic modification. So it can also include it. If I understood well the question, if not, then please.
I see no comments at the moment about this, so I assume that everything is addressed. And I would like to take the chance, we still have some minutes to go, so I would like to take a chance and ask you some of my questions. When it comes to, I imagine that if I were to be a teacher working in the field, let's say, working with students, one of the great things that fascinates them is the ability to see real examples of all these great things that you presented. So I don't know if it is a far-fetched question, but can you imagine some products that you have developed in BBEPP that students might be able to encounter and through this have a direct link to what you're doing?
I think the newest one is the one that we showed already as like a byproduct, a bio-based surfactant for the white applications from EcoWare. Another one are like additives for food, so proteins, for example. But it's mainly like an end product for us is kind of a starting material for another company to bring it together, or the lactic acid to make a polymer out of it, and then you create like a bio-based plastic that you can then touch as a food packaging, something like this. Or
you take it, basically you create something and then other companies take it one step further into developing God knows what further on.
Yeah.
Yeah. And when it comes to your own, let's say, personal journey so far, what would you say, what was the reason why you decided to turn into this kind of path? What was the motivation to pursue this kind of career, let's say? And by answering, you might help teachers or students in extension to identify and relate to some of what you say.
Yeah, Joffy shared it also already a little bit. I can add to that, and she can think about it. So I had always classes in school for biology or chemistry, biochemistry as well. And then I was interested more in nanotechnology, so it's about organic surfaces. And that's all, research intensive technologies and industries. And then for me, actually, I think it's super important, but for me, I would like to see something gaining or coming out of it. So I'm more interested actually in what happened then, how to bring it into the market, how can it be utilized? As you said from your previous question, how can people touch it and use it in their daily lives? So I was always more interested actually to what happened with the research results and how can they be commercialized, how can they be really taken up, and how can they make a change. So if we would change every fossil-based surfactants, that would be the dream, and everyday households to bio-based surfactants, that's really making an impact. So that was it for me.
Sophie, would you like to share something of your career?
As I mentioned, for me started with a microscope, and I knew that I wanted to study biology. I didn't know what, so I went to chemical engineering after the university, because it offered very broad narrowing down afterwards. So when I was already in the third year, I knew that I do not want to be a chemical engineer. I would rather go to the bioengineering, and from the different options, I just liked much more the industrial biotechnology path because it was very diverse. And I enjoyed very much working in the lab. So therefore, I stayed in research for quite a long time. And that's why I also started a PhD, because I really enjoyed, to be in the lab. I never worked with such a big, equipment that we have at BioBase. To be honest, I always enjoy the small scale, and not everyone, has to work with big reactors like we have at BioBase. You can always stay in the research field to work in small scale, and this is what I always enjoyed. But after a while, I somehow saw that it's time to get out from the lab and to look for something else. And since I was always working in the frame of European projects, I somehow wanted to keep the connection to European projects, to my academic background, to the research, and then this possibility came to work more on the project management, more on project acquisition, but still being in the field.
And I think it's one of the most amazing things when it comes to those developing sectors, let's say. There are always so many things that you could follow, so many paths that you could follow, and so many connections that you can foster between your interests and needs, the needs that the society is always please.
Just sorry to interrupt. I just saw that someone was asking for some kids material, and I put it in a chat. A book that we are aware of it, and
perfect. Thank you so much.
For children, so maybe we find it. But I could see that someone is asking already second time the same question. But to be honest, I do not understand if we can share the certificate link. But I'm not sure if I understand.
Participants will be contacted after the end of.
Okay.
And the only thing they have to make sure is to sign the signature list. So with that,
sorry to interrupt. I just saw this question coming up already.
Thank you so much. It's always good to have more than one pair of eyes on in the chat room. Thank you so much. I personally have a lot of more questions to ask. I do believe that this is a great opportunity to get a better glimpse into the field. And personally, I could go on with the questions on and on, but I'm not going to do that. I would really like to thank you once again for this presentation. I do mean it honestly, that I could sense the knowledge that you both have when it comes to what you do, and I'm pretty sure that the participants also identified this as well. Concepts and connections were presented in a really nice way and in a really understandable way. So thank you so much for this. And I would also like, as an ex-teacher, I would also like to thank you for the attention you took on presenting skills and different kind of careers that teachers could inform their students about. So thank you all. This has been a pleasure, honestly, and I'm looking forward to future presentations with both of you, Sophie and Tanya, and anything that might come. So yeah, thank you, and see you soon.
Thank you very much.
Thanks for the invite. Thank you. Bye.
Bye.